We're going to be building using actor classes. All right, so actors consist of components in Unreal. So think of the actor as the class as the major blueprint, and you can inherit. And as we've been told, you can inherit classes. We will use that in this class. Later on we will build a base class for something and then inherit from it. Right now, in terms of inheritance, you're asking: is it an actor class? Is it a pawn class? Is it something else? Components are not actors. They are coming off the Unreal object itself, but they are ready-use classes that can be used inside blueprints. So features can be included. So basically, the idea is that we can, again, rather than attaching actors to an actor, we're using components of those actors instead. So we have a light, we have a light component. We have a static mesh component. We have an audio component. We have a volume component. And these, we build up, through these components, build up our object. Again, they're showing that there's an add component button. We'll show that in a moment when we get to Unreal. Viewport. So basically, the visual representation of components can be seen in the viewport. So basically, if you add a component that has a visual piece, let me get those. So basically, the capsule component, the arrow component, the mesh component, the camera boom, the fall, these all have visual components. They have position in space. All right. These will see in the viewport. Now, the character movement, while that is inherited from the character class, that component does not have a 3D representation. It's just a component that's part of the class. So you'll see it down underneath the line right here, and you'll see that things that are inherited from another class will be noted as inherited here. So in this case, they started with the character class and they added the camera boom and the follow camera. In this case, this is what you'll see with your third-person camera. Third-person character you'll get. They've also gone down, and they've also down here a variable section. They've added my turn rate, my base lookup turn rate. So they've added variables to the class as well. Construction script. So this is a special function that all active blueprints perform. When the first blueprint is first added to level, when there's a change to its properties, or when the class is spawned at runtime, you won't use the construction script very often right now, but that later on, as you change things on values on the object, you'll go through this and be like, think of this as a checkup on the object in terms of how it's set up in it. So I changed the color value. Here, that value is applied to the light component, for example, or I change a property here that's applied across the whole object as needs be. So, construction won't run. So this is more. Think of this in the editor type stuff. It's important that construction won't be run on actors placed in the level when the game starts. So when you place it in a level, this runs, and it won't run again. So, move on. Here is basically they're setting the static mesh to have a specific material. And you've got a material type down here that you're setting to. So whenever material type is modified, the construction runs again, updating the object with the new material. So this is a way, rather than to you're setting something in the editor with a material, you have a property that you can set. And so materials are a property you can set. The static mesh is something that you can set in the editor as well. It's a variable we can create. Events. So again, these are these red nodes. Again, begin play is our first one. So this is when the level starts. Begin play gets called, and we've used this already. Now we've used it in the level graph, but we will use it in the, again, we'll use this in our class instead. Tick event, for those who are from Unity, this is the update function effectively. And we know how the delta seconds, so we know, again, here is add actor off world. So we're adding, we're moving 100 units per second on our x-axis. So let's read this. So basically, we have the event tick, delta seconds. For those from Unity, delta time. This is the how long it has been since our last tick. And so what we're doing here is we're multiplying that delta seconds by our movement rate, and this is right now hard-coded to be 100. I would have made this a variable. Just going to tell you. So we were multiplying that 100 by delta seconds, and then we're adding a world offset. And so we're moving down the x-axis by that amount. This is a movement node. We'll move this object by this many units. There'll be other ways to do this. I would have gone with gotten the way we're going to do is we're going to get the actor's location for the doors. We'll be using the actor doors, their starting location, and using that to slide them around. So, use tick when only necessary. It can affect performance. Yeah, like you don't really want to be using complicated things on tick. AI stuff don't go on tick. They have their own sequencing that they'll do. Collision events, we saw this again. So now begin overlap, end overlap. We now have actor begin overlap and actor end overlap. And then we also have the hit event. So if something's solid, so if we're dealing with not something that's not triggered, but it's solid, then the hit event is what you'd be using instead. Projectiles are more likely going to be used the hit event than the begin overlap, end overlap. Again, this property of one of the actors in the collision is, again, this is a simulation hits events. Now it's on the actor. It's not being shown here where that is. But one of the actors that has that set to true, these then start to operate. Mouse interaction, don't worry too much about this. This is like, hey, there are things here with the mouse, but this slide shows you mouse stuff, but it doesn't show. There's more magic behind the scenes you need to do to actually use these functions, but they're there. Mouse over, mouse on click, on release, mouse over. So if you're doing a hidden object game, this is where you would start thinking about building from. Actor instance. So again, think of the blueprint class as, again, the blueprint. This is the definition of the class. And then you create instances of that class, the actor's instances. So those are the instances of the actor. So I have a blueprint for a car. I can make it 3 different ways. one red, one blue, one green. I can have three more instances of the car. They're all red, but they all have, one has the enhanced, has leather seats. The other one has padded seats, and the other one has special cup holders. I don't know what a special cup holder is. I'm just thinking of stuff on the fly at the moment. Actually, the third one has the backup camera feature installed on it that could be on the, So, spawning actors, and this is something that you'll see. Spawn actor is the node, and it will ask for the class. Right now is what we want to spawn. It will ask for a transform or the location where it's going to spawn. And right here, we're spawning so when we hit the spacebar, we're spawning an actor at the actor transform. Not all actors can allowed to use these nodes. Typically, our pawns will. Otherwise, you have to tell the actor to, and you can override the actor to take input. Do this very sparingly. Like they're showing an example here of an actor that can take the space bar and it does this stuff on its own. This is not normal in terms of how you build things in Unreal. You are capable and you're able to, but it's not necessarily the normal way the things are going through. You typically don't have 15 different objects in the scene asking for input in their specific ways. It's typically just either the player controller or virtue of the player controller, the player pawn taking input. So while this works, it's just you need to be careful about how you build this. And that's one of the things that we'll be talking about. Destroying actor, this is basically, hey, there's a destroy actor node. In this case, we've got an example of the function here, test health. This gets called. It asks if this is below, again, health here is below 0. If that's true, that gets plugged in here as a true. And that gives us this line here. Branch node, if statements. So basically there is a Boolean or a Boolean operation that gets plugged into here. And if it's true, you go off in this direction. If it's false, you go off on that node continues. And this case is basically the destroy actor node. Again, target self that refers to the actor that this is on. So self refers to the actor that the node is on. You'll see that often a lot. You could destroy other actors. Test health of another actor, and then I remove it. It could be another way I could be testing this. Get all actors of class, and this is we're getting what's called an array. There's an event here called hide all coins. It gets all actors of coins called BB coin. We'll see this later on. Particularly, this is something we'll use in our. Again, it goes through. There's a for loop here. We will, for our purposes right now, I'm just showing you that this is. So get all actors of class. This can be a costly operator. Don't use it in the tick. Don't use it in the tick event, unless you absolutely have to. Now this can get called as part of the tick event, but this would be like a branch. I check for a situation where this now then gets called. We'll be looking at arrays and the for loop and the for each loop. Later on, we'll look at this. There's a whole lecture where we'll be using these nodes specifically. Referencing actors. So we can create. So again, all our blueprint classes are classes, just like all the core classes in Unreal, like pawn and character and game mode, player controller. These are core classes, and the blueprint classes that are created on top of them. We can create references to classes that we create. So later on, we will do the coin minigame, the collection minigame. We will have a collectible class, and that we will be able to ask the game of all collectibles that are in the scene. We can make references. We, in theory, could create a class, and when we do this with blueprint coordination. One of the things we'll do is we'll set up a trigger, and the trigger has reference to a location. But that location is another actor in the scene as opposed to a part of the blueprint itself. And we'll use that location to set an explosion event. It's a particle system we'll use, so don't worry. Again, we can create a variable So we're creating a variable here. We can set this in the editor, or we can spawn an actor and assign it to this as well. Player input. This is old. This is all old. This is all old. Let me jump into Unreal and show you the. I need to correct those slides now. Oh boy. All right. Any questions? I've gone through this pretty quickly so that we can get through these slides. I'm going to show you the input system quickly. Any questions for me? Yep. Are you using the developer account?
There's only one account here.
Okay, then you can't log on to the machine. Yeah, we're playing whack-a-mole with the machine still. You can give me the number on that machine. If you look at the top, it's like C something 200.
C0251
7.
32.
Okay. Put that on your keyboard. I'm gonna create a new folder. Really? There we go. All right. So I'm going to start with the Lab02 file, and I'm going to go in and I'm going to file, save, current level as. Just so that I've got this over here separately. No. Okay, so I think during lab I basically created this version, another version of the example. Yeah, I'll leave them. I'll do my work over here. So, all right, let's start with the. So let's build a new blueprint class. We can go up to tools, and there is a new, it's not here. Sorry, it's here. Here is new empty blueprint class. So it says empty, but don't worry about it. We can inherit from stuff and it won't be empty. So create a new empty blueprint class. And we're going to be working from an actor. So an actor can be placed and spawned in the world. So what we're building right now are just actors. We're not building anything that is like a character or a pawn or anything else. It's anything special. So majority of the time you will be starting with actor unless you're doing something very specific. So we will name it right here, and this is going to be hello world BP. In fact, I'm going to go with BP underscore hello world. We'll go with the full word. And you will see that this is a place of debate. You'll see a lot of people saying, so what BP underscore means that this is a blueprint class. And there's a debate whether you should be doing this or not be doing it. Epic does it. And that's the reason why I follow that convention. Now, there will be places in studios where you're like, no, that's not a good idea. But for the most part, Epic uses BP somewhere to indicate that a class is a blueprint. And it helps sort, like if you're looking for things quickly, you can do BP underscore or BP whatever and find what you're looking for. This is an old holdover from what's called Hungarian notation. And the Hungarian notation basically says you name variables with a prefix indicating what type it is. And this comes from late 80s, early 90s when IntelliSense wasn't there to help you write your code. And it's a C++. It's a C++ convention that still exists within Unreal Engine to a certain extent. So they still use, they still use it. We're going to use BP. You should use BP. I just want you to know that there's another argument out there that you should be aware about. All right, so we'll save that hello world and so again, here is my window for that blueprint class. I can dock it up here. And you should be docking your windows up here on a regular basis. Or docking your windows onto another window, for example. The content draw is a window, effectively. So you could dock that, most people dock that on another window. So the button I want you to know right away is to compile. As we make changes, go hit compile. Oh, that's new. It's now saying good to go. So we're going to make changes. So we're going to add things in this component section. So you've got components, pieces of the blueprint. So this is graphs. There's the event graph. There is the construction script. We'll worry about that another time. There are macros, which are a variant on the function, but not as, I find them not as powerful. So you will see me build a function over a macro. And variables. One of the things that you will have by default in a blueprint class is an entity that is considered the default scene root. And it's a component that, now as you move on, you will find that you can get rid of the default scene root. Another component can be the default for the scene root. We're going to leave it right now as, we're build as a default scene root, as opposed to having another object to the scene root. So again, we're going to add, first, again, this is all the different components. Again, we'll add a cube. And we'll make this 0.1. And you see that the cube is this is the platform, and this is parented to the default scene root. Here's static mesh. This is the material right here. And I'm just going to use something that stands out. Use cobblestone for our purposes right now. And again, you can see as we go, I'm trying getting closer. You can see the material stretched here. Don't worry about that. That's because we stretched the model. Not much you can do about this right now, and don't worry about it. Yeah, where you are right now, don't worry about it. In terms of prototyping, put down a cube, throw material down, you're good. Don't worry. And the thing you can also do is you can right-click here and rename. So rather than just being a cube, we can call this platform. And you can see down here in components, we're getting variables for our different components that we're adding. This is by default, Unreal's adding these variables for us. Next one that we want to add is it's going to be a volume. can't. Actually, it will be box collision. And you can see that it comes in. The big issue that we're dealing with is that the shape under box extent is coming in at 32, 32, 32. We really want that to be either 50, 50, or by 50. And that will match the shape of, excuse me, that will match the shape of the platform cube. And it's also in the middle of it, so as we move on, again, we will, you see, so we'll move this up. We can drag this. So let me, that's one, it's gonna let me, so my grid set at 100. Let's set this to 50. You can see that we come in. It's close. I think it's 60, I think. No, 55. So there we go. So basically, again, when we squished the cube down to 0.1, it was 10 high. We've got 5 above and 5 below the 0 line, so we just need to push this up 5 units. So, and just for argument, we will rename this to be collision. And finally, the last piece that we will need is a point light. And we'll move this up to, we'll say 150. We'll do 100. There we go. And we'll just give it a light color. We don't have to, but we'll just give it a light color for our purposes right now. That's red. We can go in later and we can adjust that. We can adjust that light color on the entity itself when we go. So now we've got our 3 pieces in play. We can actually go. And now the one thing that I've done is that because I had the collision selected, and when I created the next object, it was parented to it. So I don't really want that the collision parented to the point light parented to the collision. So I'll just move this up to the scene root and attach. It asked if I wanted to make this the new route, but don't do this right now. For our purposes right now, just work with the default scene route for right now. All right. I will go and I will compile. Because I made changes I needed to compile, and that will be on a regular basis. If you make a variable, you need to compile it, and then you can then assign it its default value. We saw that last week. So, and hit Control-Shift-S to save the blueprint itself. So let's go back into our file, our level. And I can go to my content draw, and we can go to lab 3, and then here is that blueprint. Here we go. Here's the blueprint. And I'm going to just basically drag that into the world. Why is my snaps not on? It doesn't feel like it is. And I'll make this 2 times bigger. Made everything bigger. Again, as we are starting with the light on. So we've got an instance of this in our level. I'm going to do Control V, make another instance of that. In this case, I can actually go to the point light component, and I'll go and let's make this green instead. Let's not make that so green. I'll do 0.5. And then I'll, no, I don't want it. There we go. I'll make another copy of that. I'm playing with the internals. So when you're working with the whole object itself, make sure you're selected up. So make sure you're selected on the whole thing right here. If you were working on the whole object, I was actually adding components to stuff on the fly, which you can do. But I'm gonna copy and paste the whole object. I'm gonna undo that. There we go. So rather than do the editor here, do it from over here. So, and then I'll make this one. Make this one blue. Okay. So what's going to happen is basically, and let's move these out a little bit further. Oh, let's go. So we get more range between the lights. Okay. I can move this one up a little bit. In theory, I could probably change this is the light volume. The range that the light is going to go. I probably could turn that down, but I'm not going to worry about that. That's a art feature, and we can go in and change that here or on the class itself. All right. So I'm going to go in. I'm going to go back to the blueprint, and I'm going to go script it there, and all three of these entities are going to have that same scripting. That's the benefit. Like in the example here, if we look, I'm going to bring up the level blueprint quickly. Here is begin overlap for that volume, trigger volume, and then we go up here. Oh, look, there's another trigger volume overlap. So I've scripted them twice in the level blueprint. We won't have to do that. We can just do that once. All right. We can ignore the construction script because we're not doing anything that requires it. So you'll be, again, our primary work was in the viewport, setting the components we want. Now that we've got that, we go to the event graph. By default, the event graph has event begin play, begin overlap, and tick. We're going to get rid of tick. We're actually not going to use begin overlap, but we will use event begin play. And we'll get a reference to the point light. That's set. There we go. And we'll use the set visibility. And then hurrah, basically here is now when we play, all those lights will be turned off. And we compile. Again, I'm going to compile. Again, I don't have to save, but I will save because I'm paranoid about not saving. And then if we press play, we can look over here. You can see that those lights are now off. I need to pull that out of the wall. So let's just make our lives easier and pull these out of the wall. Okay. In our case, I'm actually going to click on collision, and I'm going to do right click in here and call a function on collision. Open up collision. And should do and there's a component here, add on component begin overlap. So I'm going to do my collision based on the component in this case. Now we could do the actor. I'll do another version where we don't have a collision. We can do the actor itself. And then I'm going to, again, click on collision one more time so I can get context for it. And then we'll do the end overlap. Here's, again, add on component and overlap. And what is the other, what is the overlap component? What is the other actor we're dealing with? The other component we're dealing with, other information you can grab here. But for us right now, it is really, again, I'm going to grab these two nodes, copy and paste, do it twice. So N overlap, I don't need to do anything because the set visibility is off already. Again, note there is a checkbox. It's hard to see. So if you don't know that it's there, you know, for you as your first time going, you may not see it and not realize it's there. And a couple of you didn't see it in the lab last week. So that's not your fault. That's Epic didn't make the border around that checkbox bright enough. Yeah, that's something they could improve. Anyways, we will connect overlap here, and we'll turn on new visibility. So we'll turn that on, and then we can compile. I'll press play, and my boxes are over here, and then we can go, that's on, that's on. So we've done what we needed with, you know, that scripting. All right, I'm going to do this one more way. I'm going to create a new blueprint class. And we can create it, so we can right-click here, bring up this text menu, this menu here, type blueprint class. Again, we'll do actor again, and it's going to create it in this window right here. This will be BP. Hello world, actor only. I'll jump in. I'm going to add a cube. Again, I'll make this point 1. And then I'm going to add the point light. Move this up 100. And just for the sake of argument, I'm going to make this one purple. All right, jump to the event graph. Won't need tick. We will use actor overlap this case. If I can, yep, I can get away. So I had those notes in my clipboard, so I was able to paste them in. Hooray, this is a trick. So you can copy and paste nodes. Epic does its best to keep those relevant. So in this case, again, because I didn't change the point light variable, it just kept the value of point light. So I got away with what I was doing here. Ideally, I should really assign that correctly. I'll plug that in. I'll grab these two. I'll paste these down. I'll plug these in, I'll turn on visibility. And then the other actor that I want is actor and overlap. And I can paste, again, those nodes again. Again, I'm making sure it's off. So I will compile, and then I will drop this new one into the scene. I'll drop them right over here. I'll drop them right here. And where is it? There it is. All right. So things that I need to do with this one right here is that I need to go to the cube, and we'll look for collision. It's generating overlaps. Actually, this is the case where I want the cube to be my default scene root. I'll compile. Let's go back to the world. Save everything. Why are you not? Sorry, I want to overlap all dynamic. There we go. And I didn't move the light, but that's okay. But you can see that it's now sort of glowing in a weird way because the light's not where it's supposed to be. But basically, I've now had to move, basically I moved the, let's go back to it. Let's go back to the viewport. Because I parented the cube to it, the light got, yeah, it's 100 relative to the cube. Because the cube is, this is one of those weird things, because the cube is only 0.1, I really need to multiply this by 100. So this would be 1,000 units relative to the cube. And that's because scaling is in play here. This is why we kind of don't want to, like, if you've got an actor that's scaled, things get weird with the other actors. In fact, this is probably 3,000 when I think about it. There we go. And again, by making that change the class, I've made change to here as well. Also, it's only a size of 1. So there you go. There's it now acting more like we would expect it. So one of the things you're going to have to watch out for is what are you colliding with? Again, when you're asking for the actor component, the actor version of it, you are then asking for what is the component that is the root, effectively. And because we had a scene component, we had no collision regarding to it. And this is where things, again, this engine can get really complicated really quickly if you're not paying attention. So just be mindful of what's going on. So I wanted to make sure you understood basically the other way of doing things with the actor and some of the pitfalls that we had with it. All right. All right, I am going to delete these actors. And I'm going to go to I'm going to, there we go. Make it not so dark, because basically we're going to work on something that's going to need, we want some more light in this case. I'm going to grab, so I'm going to take out these ramps here, these pieces right here. I'm going to bring this out, and I'll make this only the size of 1 now. Uh, 40, we'll do 15. Copy and paste these over, and I got that by virtue of getting things. Let me see. Let's do 8 here and move this back. And we'll do 8 here. So basically, I'm just building essentially like a corridor. This back, make that 8-2 as well. Is that what I want? It'll be fine for our purposes right now. So there we go. I'm not going to worry too much about the differences between here. What this will do for us basically is I'm building an area to build out basically there'll be a door here effectively. So let's go. I'm going to close these windows right here because we don't need them open. Go to my content draw. I'm going to write a new create a blueprint class. All right, and we're going to create an actor, and this is going to be BP sliding door. Now note that I'm using capital letters in my names here because I'm building classes. All right, these are classes, so don't use lowercase letters, use uppercase letters effectively. And just for the sake of argument, I'm going to put the sliding door here. And we will see this pop up with more things in a moment. So let's go into our sliding door. Let's parent this up here so we can see everything. So let's build, let me bring up, that's great, I don't care. All right. I didn't say how big. Okay, let's start by building our door, our frame. So this is going to be a cube, and this will be 0.1. And we will say that we are going to approach, so in Unreal, the red arrow is the forward direction. So we will be coming in and out in this direction right here. So I'll make this 2 wide and I'll say 4 wide to start off with. I'm gonna literally just, this is gonna be the, rename this. This will be the floor. I am going to duplicate this. This is going to be the ceiling. And I'll make this one big, and I'll put this about, I'll say 300. And that's where we're going to approximately put, so basically from here to up there, I'm going to make this a little bigger. Make this 400. No, 300 looks better. 350, there we go. I'm going to duplicate this one more time. And this is going to be wall. And in this case, I think we want to make this 175. Yeah, 175. We want to keep it 2 units, but I'll keep this 2 units this way. And then I'll move this wall over here to 300. Oh, that just snapped nicely. And then I will make this not 175. That's where we want it to be. Like 3.5. So we'll make this 4 and 200. There we go. So I've got this now effectively, basically, again, this is at 350, so this is 100. So again, what's the math here? It's at 350, it's 100 units big, half of that top means that it's a 400. So that's what we did here. I'm just gonna copy and paste this as, it'll be wall 1. And rather than 300, this will be on negative 300. So it'll be on the other side. So here we go. We could, in theory, we can add a new scene. And this is be the door frame. And for our purposes, we're going to take all these objects and just parent them to the door frame. Why are we doing this? So we can collapse the door frame and not worry about it, because our work is not with the door frame. Our work is going to be with another object. So I'm going to add a component here. It can be another cube. We know that the height is going to be 3. And this is going to be at 150. Now, this is the door. So now there's two of these doors. Now remember, we made this 4 wide. So this is only going to be 2 wide. And this will be, I think, 100 over. And I'm going to copy, paste. This will be at negative 100. Actually, I'm looking at it from, I want to say that we want to look at it in this way. So why this side? Because the arrow is moving in this direction. Our Y is in this direction. And that means when we move this door in this direction, we're going in a positive value. And when we move the door in this direction, it'll be a negative value. So we're staying with our axis, effectively. We will call this will be door B, because this is on the positive, and we'll do door A. We're moving on the negative axis. And we can do tooltip, moves on negative Y. And we can leave a comment. And this is basically on... And this is just basically here so that we have something here for our benefit. Again, move on negative Y. So that, this is just basically here for our benefit to, like, and this is like, hey, you can leave comments for other people and other things. What is the purpose of this variable? All right, let's go in. Let's get into the content draw, and let's get some materials on this. Here's the start content. Materials. So I'm just going to use... Okay, it's not letting me drop it in the scene. I'll just drop it here then. There we go, that looks better. So here we go, we've got the nickel. And then for the door frame, we'll just make this copper. And I can, it's not letting me select multiple things. There we go. And then we can go in. And we're not going to worry about things at the moment. I am going to, for the sake of argument, so we can see the doors a little bit bigger, I'm going to put a gap in them. So I'm going to put 5. And this is so we can see that little gap here between the two doors, so that we have something we can look at. This is normally you wouldn't do this. The doors would look, they would look like the models. You'd actually have models, and they would come in. Do we have a prop actually? I haven't thought about that before. Props, frame window. Nothing that would. I mean, there is a door, but I don't. Let's just take a look at. Let's just take a look, for the sake of argument, what does the door look like? There we go. Yeah. Yeah. I mean, you could use the door. I mean, this is again, we're prototyping, so we're not really too worried too much about looks. I'm not going to use the door because this is a rotating door, not a sliding door, so I'm going to just leave this alone. So we've got our physical pieces. There's one thing that we need to do is that we do need to add a box. We need a box collision. And again, we're going to box extend. I'm going to just drop this into 100 because I'm using something much bigger. 3 units high. Do I need 3 units high? No, I only need 2 units high. I do want 2.5. I'll go 3. There we go. And then I'll make 4. So this box right here is going to basically, when you walk into this, it's going to send a signal to open the doors. When we leave, it'll send a signal to basically close the doors effectively. I'm going to, so let's, let's rename this so that we have an idea. Door trigger. Rename your things so that you know what you're dealing with. Yeah, you'll see a lot of a cube, and that's being lazy. Do yourself a favor, name your things. So let's compile this, and we'll go into the level. You can see that the door almost fits. 1.5, 1.5, 1.25. Yeah, there we go. Actually, I don't need to extend it out. So I'm gonna scale it to 1.5. The entity. Won't worry about. So what will happen is that the work that we do will apply to the object as we want, and then will be scaled. So we don't have to worry about, again. And then I will actually copy and paste this. I will undo that. There we go. I'm gonna copy and paste the sliding door. There we go. I will actually make this 0.5, so it's much smaller. And I'll do 0.5 here as well for the sake of argument. So we got a smaller sliding door variant. And then I'm literally going to rotate this 45 degrees. It's not letting me do 45. There we go. And I'm going to put it here. Yeah, I'll put it here for our purposes for right now. Just so that we have another variant of the door in the scene, another instance that's a variant. In this case, basically, it's set at 45 degrees, and this will help us indicate, like when we set this up, this will know that we've set up the entity correctly. So. All right. There are 3 variables that we need to set up. And for these, actually, category. So one of the things that we can do is we can create a category. This is going to be, we'll just call this model. And I actually don't want to add you to the model. Hold on. Let me see, floor, wall. So basically, did it delete it? Yeah, it did. Hold on. So we want to do a model. Wall, ceiling. Again, we're adding a category so that we can collapse it. And you should be thinking about this. Default scene, we'll add that to the model. And then I will actually do a door. I'll bring the door down here as well. Trigger. And the door frame I'll add to the model because I don't need it. So I can hide the model. So these are the only things that we actually need to work with in terms of the door itself. The door trigger, door A, door B, and then we'll add the 3 variables here, so that so the relevant information is in this category. So the first one is going to be door slide. And this is going to be I'm going to use a float. So when you're working in three-dimensional space, working with like relative, like talking about distance in three-dimensional space, it's a float. And that's because your vector 3's basically are a float. The next two that we're going to create is basically going to be door A start. I'm going to use location on it just for the sake of argument. And this will be a vector 3. So this is a location. And this then we'll have door B start location. And I'm going to compile these. Now these two we're not going to play with, but the door slide we will. Again, we know that our unit is 2 units. So we scaled it to the brush. And then we know this is 50 by 50, so it's about. If we move this. So here's 305. It's in the door. So we don't want to move, again, it starts at 105. Let's do a door slide of basically of 170. So we have a nice lip. So when we close it, it will go 170 in the direction it needs to go. So for door A, we'll subtract. For door B, we will add to that value. Question? Or is it stretching? Okay, cool. All right. So we could, in theory, have a door A start, door B end, and a door A start and door B end. We could do that. We're going to do this differently because essentially we know how far the door is going to slide. They're both going to slide the same direction. We're not in a scenario where A is, the end of A and the end of B could be different for these two doors. We're also not building a door that has special movement, rotation on it. There's lots of ways to build doors in 3D space. Just saying. Now that we've got the door slide and its value in, we recompile, so now it has that value. Cool. Save everything, just so that we're not losing our work if something goes wrong in some reason. So let's jump into our event graph. Let's start with, we won't need an actor of begin overlap, and we won't need the tick. So event begin play, we want to set the start location and the B location. And literally we can drag this out and set. And I can do, here is the B. So let's grab door A. And you might think go actor get component, get look. No, that's not what we want. Okay. So there's a couple of transforms that we want to look at. There is get relative transform, get socket transform. There's also get world transform. So world means world coordinates. We don't want that, because that means we're going to have to deal with this in world space, and we have to know how the rotation works in world space. We don't want to do that. We want to deal with, what we really want is relative transform. Later on, there'll be the socket transform. So in Unreal, there's what's called the socket system. Basically, on your meshes, you can add sockets to things to attach things. So 3D models have sockets that you can attach things to. For those who are from Unity, you've used an empty game object effectively for that purpose. But we want to use the relative transform. And again, we want it relative to the default scene root. Now I know let me close the door frame. Yeah, so the doors are connected to the default scene route. So these are their location. We go back to the viewport. We look at this. This is at 0, -105, 150, relative to the default scene route, which is basically 0, 0, 0 in this coordinate system. We look back here. That we go. We need to get underneath the floor. It's going to be a little hard to. Come on. Hold on. Let me do something quickly. Let me grab the floor for our purposes. Let me grab this out of the way. And you can see the icon right there. That's the default route, scene route. So that's the origin of the object in the world, and so basically, this door is, because it's parented to the different scene route, it is here. We want to move relative to that position. That's why we use the relative transform. Now, for those who are from Unity, that is called the local, and you'll hear me call it the local transform. It's the same thing. It's just Epic just calls it relative, and that's because local got picked up. That became, after Unreal Engine was developed. The term using local became popularized by other engines and other platforms. So, like another editor. So if you hear me say relative, if you hear me say local, I mean the relative in Unreal Engine. If you hear me say relative, I mean local. They mean the same thing. Compile. Let's go back to our event graph. So we want to get the relative transform. Now, the transform is a structure, and one of the things you can do with structures, you can break them open, split the struct pin, and I can then now drag that right up there, and I can assign the vector 3 to the vector 3. And in Unreal, the vector is just a vector 3. I can grab this node, do the same here. I'm going to move that down. And I'll just grab, get the reference to door B, and I'll plug that in right there. So I can get the relative transform of door B. And I'll leave it like this. And I'll wire it in like this. So now when I start the level, when begin play gets called, I'm getting the location for A and B. Now let's just compile that right now. Let's go into, make sure I save everything. And I'll press play. And I'm going to go back. Where is... Here you go. Here's sliding door number 1. And will it show me the variables? Actually, let's go back to the... So, what I'm going to do right now is for these two variables, I'm going to turn what's called an instance editable. This is not what we typically want to do. So what this means that this is equivalent basically of making these public, and make these, I can change these on the fly. Not what we want to do here, but what by doing this, effectively, let's just... We go back to the sliding door. I now have this default start location, default. So I can see, basically I did this so we can see the variables here. Not necessarily what you would want to do, but I just wanted to show you that, hey, this is where it is, this is the value where it is, and it's the relative location. And I go to the other sliding door, which is in a different place and rotated, it's the same value. So I'm going to go back and I'm going to turn that off because that's not what we want, because this is not a case of where we want to edit this per edit. You know, this is not like a this is not something that we want to edit on this on a regular basis, and it's something we don't want to touch. And in fact, when we run begin play, that's going to get overridden anyways with the values we want. But we know their start location, and that's the first thing that we wanted to do. Again, we know how far the slide. Okay. I am going to go in and I'm going to grab our door trigger, and I need to stop simulating the scene. Thank you. And I'm going to go in. I'm going to compile just to be on the safe side. With door trigger, I am going to use add event for door trigger, which is collision on component begin overlap. And then I'm going to go again, click on door trigger, add event, collision, and overlap. What I'm going to do is I'm now going to right click here and type timeline.
I'm sorry.
Go. If I can spell timeline. And it's going to add a timeline component. That's not what we wanted. There we go. Add timeline. My apologies. Got the wrong. And this is going to be our door slide %. All right. So when we enter the door trigger, we're just going to click play. And when we exit the trigger, we will reverse. We could reverse from end, but we could see some jumping around. So here we go. So we've got this in play right now, and so the next thing that we need to do is basically, when they update, what we're going to do is there'll be another variable that we'll add. Basically, the door % goes from a 0 to 1. So we're using decimal percentage. So 0 is 0%, 1 is 100%. So let's double click on the door %, this node, and this will bring up another window. We will add a track. And add a float track, because we're only going from 1 to 0. Length, how long the length? I'm going to do 1.5. So I'm not going from, I'm not going 5 seconds long. We basically, my door is going to open on 1.5 is the value. I'm going to zoom this out so I can see 0 and 1. And right now what we want to do is add 2 keyframes. We're going to just right click. So I'll right click here, add key to curve float 0, 0. I'm going to make sure the time is set to 0. Value is set to 0. And then I'll set another keyframe up over here, add key. And now I'll make sure this is 1.5 specifically, and this is a value of 1. And this is all that we need to do right now to set up this track. I do want to name the track. Let's rename that. This is going to be the door slide. We'll just call this %. And now I've basically set up a timeline that goes from 0 up to 1 over 1.5 seconds. And that's all we need for this timeline to do. Could we play with this timeline? Could I put a key here? I mean, you can go and add key here, put a key here. We may, be like, hey, 1.125, 1.125, put you there. That's not, I'll do 0.25, and I'll do 1.25, and then we'll say 0.15, and this will be, in theory, 8.5. 0.85. Not what we want. Let's do 0.95. There we go. So this will be, in theory, 0.5. There we go. 0.05. There we go. So I got to slow out and it will ease, so you can play with the curve here. The idea is at the end here, as long, I don't care about the internals of your curve. All right. As long as you have a keyframe here that is at 0 and 0, time 0, value 0, and at the end you've got a 1.5 or the length, you may pick 2. As long as you've got the end of your length is 1, these don't matter. I'm going to just leave this for right now so that you'll see the slow in and slow out, the easing on the curve. And there's so much more you can do with these curves. I'm just showing you the very, very basics right now. I am going to compile and save everything. And I'm going to go back to, so here's my door percent. I'm going to go back to my event graph. And on update, I'm just going to do a print. And I grab, and you see now I've got the percent down here. I'm just going to grab that and plug that into the string, the print string. I'll grab this out of the way. Pull this out. And so basically right now, basically for testing purposes, I'm going to walk into the trigger and see the update happen, and walk out of the trigger and then see the update. You go up to 1 and then go back down to 0. And if we've got that correct, that's the first thing we got. If we've got this correct, then we're good to move on to the next piece. Save everything. And I will go up. Where are the doors? There it is. So there is door number 1. You can see that. So it's doing what we want. So now that we know we've got that, we can do the calculation. All right. Basically, the mathematic is pretty simple. Let me not what we want. All right. So the math here is pretty simple. It is going to be our start location, and we're only going to move on the y. It's going to be our percentage. It's going to be plus or minus the percent times the door slide. All right. For A, we subtract. For B, we add. And we can represent that by a -1 and a +1. So we've got 3 things that we can, there's actually 3 things that we can do. We can, and what I'm going to do is I'm actually going to create a door slide function. And it's going to take basically the start location, the percent, and slide direction. And this is going to be -1 or +1. And this will make our lives easier to do the math, basically. So let's go back to Unreal. And this is me showing you, hey, here's a function. So we will, again, door slide function. Again, basically we'll have 3 inputs. So this is going to be the door mesh. And we look down at this, at the door A, it is of type static mesh. So let's go back to our function. This will be static mesh. It'll be static mesh component. Our next is the percent. And this will be a float, because that's what we're getting from our timeline. And then we will just add one more, which will be the door slide direction. We'll just call it slide direction. And for the sake of argument, we're going to make this an integer. and then we can compile. So basically what we're doing is, sorry, not door, yeah, door mesh. Actually, we need one more. This will be the, and we'll move this up. And this will be a vector 3. So basically, we won't have to, so basically we'll plug in what we need here. So let's compile this. Door mesh, basically what we want to on this is get sorry, we want to set set, come on. So we want to set the relative transform. So target has already come in, so and then the new transform, we will just break this struct pin, so we will only be affecting the location. So first thing that we know is that let's actually go back. Let's move the door slide direction up, because we know that the first thing that we know is that the first mathematical is the door slide. We'll get that. So that's the last piece here. So it's door slide times. Actually, let's go this the opposite way. Multiply. In fact, we can actually add a pin. Actually, we can and one of the things you can do is add a pin. So I'll move this down here. Percent, slide direction. So I've added a pin so I can do all those 3 multiplications at the same time. So this will be 1 and -1. This will be the percent. This will be the door slide value that we've set down here. Then we just need to add, I'll grab it from here. We need to add, and this is a case where we need to break the struct pin, because we're only moving this on the Y. And then we can get this vector and plug this into the new transformer location. So let's go over the math one more time. So slide direction, this is how, by multiplying 1 or -1, we add, that's how we get the add or subtract. Percent, we're going to get it off the timeline, and door slide we've already assigned. So we multiply all those together, that gives us the distance that we're going to change on the Y value. We take the start position, we split so we split this pin so that, again, let me just do this one more time. We did an add, and we're going to add 2 vector 3s. Well, we only want to affect the Y, so we split the pin so we get the 3 vectors. And this is, again, we're going to only apply this to the Y. And so we've added, so whatever this value is, we will add to our start position. That will be the new position of the door, and we'll plug that into this right here. And that's all that this function needs to do. And this will make our lives much easier, because we don't have to worry about we don't have to worry about like, we've written this code once, we can reuse it. So we will compile. Let's go back to our event graph. And so basically we will just drag the node into here. So target will be itself door mesh. So this is going to be door A. So we will plug this in here. Percent will just drop down in here. Slide direction, again, negative. For A, we want -1, so we'll just drop in -1 right there. And then the start position we'll get. So one thing that you might do is forget to set the side direction. If that is 0, the door's never going to move because we're doing a 0 multiplication on what would be the delta of the door. And because it's 0, it never gives you a value. You basically throw out the percent and your direction. Again, no, we don't have to tell it how far to slide because that's a variable within the class. Grab these two. And again, one of the things I'm going to do, again, I'm going to grab this and pull this up. I'm going to basically right-click here and do a reroute node. And I'm going to plug this into the reroute node here. Because I'm going to do another reroute node over here. And I'm going to plug that into this one. And this is basically, hey, how do I keep my wires looking cool? Reroute nodes. So I literally can just grab this node right here. I can drop it over here. And I can now plug in the percent easily right here. Side direction, 1. Make sure we get that correctly. And now we just need to know which door mesh we're going to be. This is going to be B. I can plug it in right there. And then the door start location right here. And I can plug it in right here. A lot of the work that you're going to be doing, and for our purposes, I am going to not print to the log. I'm going to turn this off. Because, yeah, actually I can take these two out because you know it's working. So I will update door A, update door B. And I'll compile. Let's go jump into our level. We'll press play. I'll run up to this door. And I've done something. Let's go back to the sliding door. So what I've done in the door slide function is I've got new transform rotation and new transform scale being applied. That's not really what we want. What we want to do is actually grab the door mesh and get relative transform. And this is going to get messy. And I'm going to break the struct. I'm going to break the struct pin because basically I want to plug in its rotation and its scale in here. I want to keep those. I don't want to overwrite them. And that's what happened is I overwrit the scale, and that's why the boxes came to like smaller than they should be. So we'll press play. Let's make sure I've saved everything. You can see the door is now moving. Again. And that's basically what we would want. Again, we've got some shadow here. So just for aesthetics purposes, I'm just going to go in. I'm going to just basically add place actor, spotlight. Not a spotlight. Well, yeah, I'll use a spotlight. That'll be fine. I'll bring it up higher. To 2000. Nah, it's not. That's too high. If I could, and then I'll crank this up to 16. Is this doing what I want? It's not doing what I want. Hold on, I just want a point light. There we go, point light. There we go. I have a shadow that I don't like, so I'm just going to put a light in for our purposes. This is just me being a level designer and being see this better now. Again, I can walk out of the trigger. Again, here's the door. Same scripting, same object, scaled differently, rotated. And that's the goal of this week's lecture, is to get you to do something. Again, there's a lot of math here. There's a lot I'm throwing at you really quickly. This will take a while. And there'll be a lot of questions in terms of scripting. But you will have at least this video to fall back on. I don't have you use a function in the description of the... You should use a function. Honestly, you should get used to creating functions. Writing a function, again, if you didn't have that function there, then the math would be, the nodes would get really complicated pretty quickly. It would be much more messier than what we have. And if we go look at the sliding door again, the one weird thing right here is this piece right here. Again, I've got the door. I had to do this to get this to work. You might go in this direction. I don't know. You're still crossing streams. That's the one thing is I try not to cross wires because it adds complexity to how you read it. So I think I'll leave this as it is. Let's go back to the event graph. Why that again right here? We just had to plug in the %, give it the door direction, door mesh, door position. We were good. Same thing over here: door mesh, door position, % direction, and we knew everything we needed to do. What we needed to get that done. And it made this again made this section right here much cleaner and easier to understand what's going on. And that's the whole point of using functions, is that we are making our own nodes that do something. We made a node to move the door. And that's the purpose for these functions. This is particularly in Blueprint. You'll see it's okay to go function happy, because the idea of the functions is to isolate operations into a single unit, such as this single node, so that you don't have to do all that work and duplicate all that work over and over. What if I had 5 doors that were moving? We're sliding in their own particular way. What if I had, what if you had, multiple things that you were doing? The function was going to help you sort that out. And will make the event graph easier to read. That's the other thing, is that by having this node, I've made my event graph much easier to read. So, and you can see again, like this is both of these are not the same the door that I built. This door right here is scaled 1.1225 to fit this block area. I scaled this down 0.5. I could go 2 and make it much bigger. So the only thing about this tactic of what we've done here with using the timeline, basically, the problem that we have is by using the timeline, we are kind of stuck at the time that we built it with right now. And there's ways to handle that, but it's a lot more work. So that's the only thing, is right now we are tied to, like right now I built it to 1.5 seconds. We're tied to that, to this entity right now. If we were to build another version, we needed a different timeline, a different length. We might have to build a different door type. But again, we're trying to think of like, hey, in my level, I'm going to have a door. I'm going to have a door in general that I'm going to have all the time. there's if we're building the Enterprise, well, the turbolift doors are a constant door across everywhere. There's the captain's door. I mean, that's a common door in the hallways. We're not gonna. Those are not being built bespoke for every person. The most you might do is change materials on it to represent who's on that door or on the. So there's. Think about reuse. Think of that. This is now a tool that we've just added to our tool chest. Hair designers, here's a door you can use, and it does this. Extra credit if you give it, it's locked. Extra credit if you can pick up an item and it knows to tell the door to unlock itself. And I'll give you a hint on that. On the door in this and I just need to move these up into the function area. And I'll just is locked. And that would be a Boolean. And I'm going to say for argument's sake, it is instance editable. You can edit that in. You can edit that on the object, so the door can be open already, is unlocked already. We can compile, and again we can say, or maybe the door is locked by default. I'm going to leave this unlocked for right now. I'm going to leave it unlocked, but in theory, we could turn this on. Now, it's not going to do anything because we don't have anything in regards to that, but this is the start of working in that direction. I'll compile, so we now have, and I'll drop that into the door function. Now we have that Boolean down here. So hint towards what you need to do for that extra credit. Those of you who are, this is not that big of a deal. Go for that extra credit. I'll give you the other hint. This is something we'll see later on. Basically, we will do a new function called unlock. We'll call it unlock door. And that is basically, we'll say set this variable. For our purposes, all we need to do is just basically call the function and turn this variable off. Is locked. It's not locked. Then we can do, we're unlocking the door. And conversely, you may want to, because your designers want it, a locked door. Again, this is just basically is locked, not get, it's a set. Not part of your assignment, but it's a clue to things that you can do later on. By making functions, you then you have an interface of things you can work with. So this can be called by another object. Is basically what is why we would make these functions. So, in theory, because this is an instant editable, we can it can be edited by other objects, so we could go that way. But having a function makes it more it's more tangible. It's like what are we're just setting a variable. Why? Here's a function. It has a name. It has a thing it does. So this is something, naming things and how you name things is something that I will work with you over time. It's an art to how you name things. And it's something you'll learn over time. As you write code, you'll pick this up. So don't worry about, I'm showing you like really clean code. I'm showing you really cool things. I've got decades of work of writing code, and I've written a lot of bad code. I'm showing you the best ways to do things right now. These not necessarily the ways you would think of right away. So don't feel bad. Don't worry about doing it the right way. Again, the first, just remember, your code has to do two things. Number one, did anyone want to guess what the first thing your code has to do?
Work.
Yeah, work. What's the other thing it needs to do? It needs to be maintainable. And by maintainable, it needs to be readable. Because if someone can't read your code, and they can't maintain your code. They can't see that something had gone wrong. Again, we go back to, when I opened up the door for the first time. Let's go back to the function. Let's just break these for a second. Again, this is the one that we need to break. So when that happened, let's compile, let's just open. Again, when we saw the doors, I mean, it moved the objects, but it scaled them, which is not what we wanted them to do. So, again, I can plug that in. So again, being able to read your code is important as well. There's ways to write your code that make it harder on yourself. We will go over that over and over, and that's something we'll talk about we'll talk about good blueprint. Again, the big one here today I'm showing you is use functions. When in doubt, make a function out of something. If you're doing a particular operation, make a function out of it. So you isolate that operation into its own node. Those of you in my Unity class, there'll be lots of different ways that we've already talked about. We've already talked about different ways of writing code in that class. So these will be instilled in you, whether you're writing C#, C++, whether you're writing Blueprint, whether you're writing JavaScript, or something weird, or dealing with HTML, or CSS. There'll be a way to write that makes sense, that other people can look at that and make sense of what you're writing. All right. Any questions before I let you all go? Okay. Expect this to be uploaded to YouTube after 5 o'clock today. Just so you know.